Okay, so this is October 2024 paper, Unit 1. Question number 1 is what is the molecular formula of naphthalene? So in this question, of course, the structure is given to you. So what you have to do, you have to count the total number of carbons and total number of hydrogen atoms in this one. This is the skeletal formula. It's quite confusing, but you need to know how many hydrogen atoms are attached. This is one, this is one, this is one, then one, then one, then one, then one, and then one. You can count the total number of carbon atoms in this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it has to be 10 carbon atoms, but it may be B, it may be A, right? Because in both options you can see 10 carbon atoms. And then we have to count the total number of hydrogen atoms. I think total number of hydrogen atoms are 8, so it's gonna be A. Okay, in this way, you can solve these type of questions after counting each and every atom. Magnesium azide is an ionic compound, okay, containing the azide ion. The empirical formula of magnesium azide is this one. They have told you that it's going to be N3 minus, right? It's going to be N3 minus. So what would be the formula? What would be the formula? The empirical formula of magnesium azide is. Yes, they are asking the empirical formula. So what do you say? First is Mg3 and then we have MgN2, then we have MgN3, then we have MgN6, by the way. Hmm? Since they told you, right? It's N3 minus, it's going to be minus. And by the way, N3 minus has a -1 charge. You know, they have told us that it's going to be -1. N3 is equal to -1. So after looking at the charge, then what can I say regarding the formula? Okay, B is incorrect. B is incorrect, by the way, because nitride, azide ion has 3 nitrogen atoms. This is incorrect because in this you can see 2. What about C? What about C? So C is also incorrect, because the charge of magnesium is +2. The charge of magnesium is +2. Okay, so the charge of magnesium is +2. What does it mean if this is +2? So magnesium is +2 and nitride is going to be -1 when I would be putting the charge of 2, because whenever we write down the formula, so the charge is swapped. So it is like that. It's going to be Mg1 and N3 multiplied by 2, isn't it? So that's why the formula is going to even not A. Remember, let me tell you one more example. Let's say if I have aluminium oxide, what would be the formula for aluminium oxide? Aluminium is in group 3. So the charge for aluminium is 3. Oxygen is in group 6. So the charge is 2. If this is 3 and this is 2, so how do we write down the formula? We always swap the charges. So we can see it would be Al2O3. So that's why in the same way I'm going to do working. It would be like that. That's why the formula for magnesium azide is MgN6. That's why. Okay. Then how many oxygen atoms are there in 0.0100 mole of sulfuric acid? So what is the formula for the number of atoms, right? So number of atoms is equal to mole multiplied by 6.02 exponent 23. And then we can see that in sulfuric acid, how many atoms we have? 2H, 1S, and 4O. So 2 plus 1 plus 4 is equal to 7. So I have to multiply this by 7. So how many moles I have? 0.0100 multiplied by the Avogadro's number and multiplied by the total number of atoms that are present in sulfuric acid. So, of course, after the solution, you would be getting C. So the answer is C finally. So in this question, you need to know about the total number of atoms, right? Because sometimes they give sulfuric acid, sometimes you will see ammonia, sometimes you will see anything else, sometimes you will see HCl. But this is confirmed that when they would be asking about the number of molecule, when they would be asking about the number of molecules. So in the case of molecule, you are not supposed to multiply with the total number like that. Right now I'm multiplying it. So remember, you have to note it down. In the case of only atoms, you have to multiply. You have to multiply this. But in the case of molecule, you are not supposed to multiply. Okay. Then question number 4. Then question number 4, two identical sealed flasks containing different gases. Okay. Mm, right. Each flask contains one gas with the gases at the same temperature and pressure. Flask A contains 4 mole of methane. Flask B contains 160 milligram of a different gas. Which could be the gas in flask B? Okay. First of all, I have to find out the number of moles. Okay. And moles are given, by the way. We have to find out the MR. So MR would be equal to mass over N. MR would be equal to mass upon mole. Right. Mass upon mole. So they have given you the
Answer are
mass. Sorry.
the answer is A.
Answer is A. Okay, let me solve it. 160 milligrams. So I have to convert it in a gram. So 160 upon 1000 is gonna give you 0.16 divided by the mole, that is going to be 0.004. Like the same thing, of course. Let me write 4.0 exponent minus 3. Okay. At the same temperature and pressure. At the same temperature and pressure, the number of moles of gases are same. It's a concept. Hopefully you know the concept. At the same temperature and pressure, the number of moles of gas are same. So that's why I'm taking the mole of A, not B, right? And then what's the answer that you're getting? MR, of course, it's going to be 40 because the mass for argon is 40. MR is 40, around 39.948, around 40, yeah. Because helium is 2, neon is I 20, carbon dioxide is 44, so one and only 40 is correct. Diphosphane reacts spontaneously with oxygen. The equation for this reaction is balanced. Okay. When? So how can we solve these type of questions? Uh, the first method is that the numbers that they have given to you, the numbers that they have given to you are supposed to put that numbers. You are supposed to put that numbers in this equation. And the option in which after putting the numbers, the equation is balanced, that would be your correct option. And the second way to do this question is that balance this equation by yourself and then like you can match you can match your numbers with the options. So uh, P2, P4. So I'm supposed to put 2 over there, isn't it? And like what the rule says, What's the shortcut way to balance the equation? Number one, balance the metals, then balance the non-metals, then balance oxygen, then balance hydrogen. These are the rules to balance equation, okay? So phosphorus is balanced, and then I have to balance oxygen, 10 oxygen, and over there 2 oxygen atoms, so I'm supposed to put 7 over there. 7 into 2 is 14, 10 is already there, so I'm supposed to write 4. So it's gonna be C. So it's gonna be C. As I told you that if you are feeling that, like if you're not comfortable with this, you're saying that all the time whenever we balance equations, so we take like it took so much time. So the only thing is to know about that you have to try the different options. First of all, you have to put A, then you have to try B, and then you have to try C and D. Like in which case you will see the balanced equation that would be your correct option. Copper metal can be can displace silver from silver nitrate solution according to the equation shown. 10 grams of copper metal was added to an excess of silver nitrate solution. Okay. The silver metal was collected, washed and deionized, washed with deionized water and left to dry. What is the mass of silver metal collected assuming 100% yield? Mass of silver metal they are asking, and they have given you the mass of copper. So after the mass of copper, that is 10 grams, okay, we can also find mass from the mass, but we can also solve it through the moles. Like I mean to say, let's say I'm taking copper and I'm taking silver, right? The MR of copper is 63.5, right? MR of copper is 63.5, and the MR of silver is 107.9. And they have given the mass of copper is 10 grams and they're asking the mass of silver. So of course I have supposed I'm going to cross multiply this. I would be getting 10 multiplied by 2 into 107.9 divided by 63.5. So what's the answer? The answer is 34 grams. So 34 is in between 20 and 40, isn't it? So that's why C is correct, right? Question 7. This question is about the thermal decomposition of calcium nitrate. What volume of gas is produced by the complete decomposition of 0.050 mole of calcium nitrate at room temperature and pressure? They have given you the mole of calcium nitrate and they're asking the volume of gas. Volume of gas is produced. We have two gases in the product side, NO2 and O2. So how many moles of the gases are produced in total? I will say 5 moles, 4 of NO2 and 1 mole of O2, right? So, uh, okay. So what can I do for that? First of all, I can say calcium nitrate and the gases. It's gonna be 2 and it's gonna be 4 plus 1, 5. If I have the moles of calcium nitrate, that is 0.050. That's gonna be X. So let's say X is equal to 0.050 times 5 by 2. Okay. It would be the mole of gases. Let me solve it. 0.050 multiplied by 5 divided by 2 would be equal to 0.125 mole multiplied by the volume, like the multiplied by the molar volume, that is going to be 24. Okay, to get the volume, so I'm getting 3.00 decimeter cube. So yes, the answer is C. Okay, right. Because they have not specified the gas. They were only saying the gas. So what do you mean by this, the gas? Because we have to see the chemical reaction. So I saw the chemical reaction and I have decided that in which I have 2 moles of gases, like two gases are produced. One is NO2, another one is O2. So then I have totaled the number of moles of gases and then I took the mole ratio. Ethanol is formed from glucose during fermentation. What is the atom economy? Yeah, over there you need to know the formula for atom economy. You know what is atom economy? The mass of the desired substance, the mass of the desired substance divided by the total mass of the product. Okay. In this question, the mass of the desired substance is ethanol. Like they're asking the atom economy of ethanol, and ethanol is in your product side. So what I would say, mass of ethanol 2 multiplied by like I can say mass of ethanol, total mass of product, then multiplied by 100. So mass of ethanol is C2H5OH. It's going to be 46. Okay. Again 2 multiplied by 46 plus 2 multiplied by 44 because carbon dioxide is 44 and multiplied by 100. That's the atom economy. Depends on the chemical equation, right? So the answer is C. Okay. The table shows some data about fundamental particles in an atom. An atom of hydrogen can be represented as H1. So what is the mass in grams of this hydrogen atoms? Of this hydrogen atom? The mass in grams. The mass in grams. So mass in grams means that like I can say that proton is 1.6725 exponent minus 24 plus then the mass of electron is 0.0009 multiplied by 10 power minus 24, right? So then the answer would be 1.6734 multiplied by 10 to the power minus 24. So means that the answer is to be B, isn't it? Now you are thinking that, sir, why didn't you take the mass of neutron? The thing is that they have mentioned the element that is hydrogen. And if I can say in this hydrogen, I have 1 electron and 1 proton and 0 neutron, isn't it? So it has 0 neutron. If it would be having neutron, so ultimately for sure I would be taking the mass of neutron as well. But in hydrogen there is no neutron. It has 0 neutron. So that's why I didn't take the mass of neutron. I only took the mass of electron and proton because in this element we have electron and proton. That's why. Let's say if it would be having 2 electrons, 2 protons, 3 neutrons. So of course I not only I have to take the mass, but also I have to multiply that mass with the total number of electron and proton. That's the method. Okay. Which of the particles would be deflected by an electric field? Of course, the particle which would be having charge, common sense. So electric field, so I would say electron and proton because only the charged particles are deflected, right? Only the charged particle, only the charged particle will be deflected, right? This question is about the period 3 elements: sodium, magnesium, aluminium, silicon, phosphorus, sulfur, and chlorine. Which statement is not correct for these period 3 elements? Atom of chlorine have the highest first ionization energy. You know, across the period, ionization energy increases due to the decrease in size, and down the group, ionization energy decreases due to increase in size. You need to know this one, okay? So as they have mentioned the elements sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. So so uh, of course ionization energy is going to decrease. This statement is correct, right? But they are saying not correct. Ions of chloride and sulfide have the same ionic radius. Ions of chloride and sulfide has the same ionic radius. How is that possible? Chloride 18 electrons and sulfur also has 18 electrons. They both have the different charges. So despite that they have different charges, their sizes are supposed to be different, but they are saying the same size. So this statement is not correct. This is the true option, isn't it? Shh. Uh, and let's try see as well. Atoms of sodium have the largest atomic radius. Sodium has the largest atomic radius. This statement is correct, yes, because across the period size decreases. Sodium is going to be the largest. And they're saying atoms of phosphorus have the most unpaired electrons. So we have to write down the configuration of phosphorus. You know, phosphorus is 15. So the configuration of phosphorus would be 1s2, 2s2, 2p6, 3s2, 3p3. So it has three unpaired electrons. So but they are saying most unpaired electrons. This statement is also correct because it has three unpaired electron in all the whole series. So that's why this statement is also correct. But they were asking the not correct. So that's why I have ticked option B. The melting temperatures of these elements are shown in the table. Yeah, silicon is at the top because it has a giant covalent structure. Which of the elements has the strongest intermolecular force? Strongest intermolecular force. So remember, intermolecular forces are not present in ionic bonding. Intermolecular forces are not present in metallic bonding. Let me write it down. Intermolecular forces are not present in ionic bonding and in metallic bonding. The concept of IMF is related to the covalent bond, remember. Okay? So which one is a covalent? You need to like clarify this. Which one is a covalently bonded? Of course, aluminium is a metal, it has a metallic bond, silicon is a it has a giant metallic covalent structure, right? So, but despite it's a giant covalent, only in a graphite, IMF is present. You need to write it down. These statements are very important for the next paper, right? And phosphorus and sulfur, they both are non-metals. They would be having a covalent bond, but the thing is that phosphorus exists in the form of P4 and sulfur exists in the form of S8. Also, this is information. This is very important information. Kind of, I can say it's a concept as well because the student must know that which element has, like which element is present in which form at room temperature and pressure. So we need to know phosphorus is a tetraatomic molecule and sulfur is like it has 8 atoms. Okay, we must know this. We must know this. So the number of atoms are directly proportional to the intermolecular force. If the number of atoms are higher, means that the number of electrons are higher. When the number of electrons are higher, so means IMF is higher. So that's why it's going to be D, right? Which row of the table shows properties consistent with the type of bonding shown? Ionic is always soluble in water. Melting temperature is always high. Conductivity of solid. Yes, A is correct, isn't it? Let's try B as well. Ionic is soluble. Temperature low? No, it's not possible. B is incorrect. C, metallic, soluble in water. It's not 100% true that all the metals are soluble in water. It's wrong. Yeah, C is wrong. Then D, metallic, insoluble. Okay, high temperature, but poor. Why poor conductor? Metals are good conductor. Metals are good conductor at any state, whether you have solid, whether you have liquid. Which ion is isoelectronic with a noble gas atom, group 0 or 8? So isoelectronic means that it's going to be completed. Like noble gas has 2 or 8. 2 or 8. Like, of course, we have to see the periodic table. Helium is 2, then neon is 10, then argon is 18, like that. So let me tell you an electron. Hydrogen is having plus 1 charge, so it has 0 electron. It has 9 electrons. You know why? Because oxygen is 8. In the periodic table, the proton number for oxygen is 8. So 8 minus 1 is going to be 9. Scandium, the proton number for scandium is 21. It has a plus 3 charge, means that we have to subtract 3 more electrons. After subtraction, I would be getting 18. So yes, it's going to be correct. 18 is equal to argon. 18 is equal to argon, isn't it, right? Zinc is 30. Proton number for zinc is 30. So 30 minus 2 is 28. So 30 minus 2 is 28, right? So, but 28 is not a noble gas configuration. That's why C is correct. Or then cycloalkanes undergo free radical substitution reactions by the same mechanism as methane. Three isomeric cycloalkanes are shown: isomer X, isomer Y, isomer Z. Both have 5 carbon atoms. You can count it, right? Which react with chlorine to produce 4 different monochlorinated products. Like, it's a very tricky question, like through like related to isomerism. The thing is that in this question, you have to first react with chlorine. Okay, you have 3 options, right? So um, and then you have to see, how many, like they have mentioned that 4 different monochlorinated products would be produced. 4 different, right? So let's try isomer X. Let's say chlorine is attached over there, then may attached over there, it may attached over there, it may attached over there, isn't it? This and this product would be the same. I'm not counting it. So it's giving 4. Let's try Y. This I'm not I'm not writing down chlorine over there because these two positions are same. I'm counting it as 1, and this is going to be like that. This is going to be like that. Again, I would say that these positions are same. So the red one is not accepted. They are the same position. So even it's not giving the 4 monochlorinated product, it's giving 2 monochlorinated product, isn't it? It's giving 4 mono. Let's try Z as well. So I can say chlorine is there. I can say chlorine is there. Okay. No, they are the same position. Sorry. I'm not going to accept it, right? I'm not going to accept it. They are the same position. And then I can say the chlorine is attached over there. Then I can say it's there. Then I can say it's there. So 4 monochlorinated products. So yes, isomer X and Z. So it means that B for ball is correct, right? So the thing is that for the isomerism, you must be good at in drawing a structure, especially for when some halogen is attached. It may be chlorine, it may be bromine, right? Uh, kind of, I can say, if uh, regarding isomerism, if your practice is good, so you can do these type of questions in a limited amount of time. Otherwise, these questions will be taking your lot of time. So uh, now it's up to you. Like, what are you feeling right now? If you are feeling that I'm good at like this isomerism, so you can solve this question easily. Otherwise, you have to do practice. Okay. Now see question number 14. Question number 14. Just read this and then I'm going to tell you. Polymerization of alkenes occurs via free radical mechanism. This reaction is started by the addition of small amounts of another compound. The structure of one of these compound is shown. This can be represented as ROOR, where R is this one. Okay. Which step in the mechanism is an initiation step? If you remember, like I told you, how can we identify each and every step? So you are supposed to write it down. In initiation step, radical is present in the left hand side. In the propagation step, radical is present on both sides. In the termination step, the radical is present on the product side. This is very important. So it would save your time. It would save your time, right? Otherwise, you have to identify by yourself, of course. Yeah, like the reaction it has its own concepts, but this is the shortcut way to identify, right? So in initiation step, what I told you, radicals are present on the product side only. So yes, the answer A is correct. Radical is only present on the product side. Reactant product both. This is propagation step. Reactant. So this is termination. Reactant product both. This is propagation, isn't it? Right? This question is about cyclohexene, a cyclic alkene. What is the general formula of cyclic alkene such as cyclohexene? So So you can count this number one, two, three, four, five, six. We have six carbon atoms. Then we have to see the total number of hydrogens. One, two, three, four, five, six, seven, eight, nine, 10. It has 10 hydrogen atoms, right? I can say that the double of carbon and then minus two, isn't it? So yes, CnH2 and minus two, it's going to be B. It's an idea, isn't it? The double of carbon is hydrogen should be 12, but it's 12 minus 2. As we saw in the given molecule, it was 10. So yes, this is the formula. CnH2 and minus 2. Cyclohexene can form an addition polymer, which diagram shows two repeat units of this addition polymer. Cyclohexene. It's mean that It means that this is going to be cyclohexene. Let me write it down. Cyclohexene, right? This is the double bond. This is the double bond. So they will be attaching over there, isn't it? After attachment, double bond will be removed. Okay, so that's why. What do you think? Is that correct? No, because it should be the continuous chain. Just adjacent carbon. Oh my God, what is this? If the double bond is there, so why they are making a continuous chain over there? No, incorrect. Oh my God, incorrect. Because double bond is there, right? So they are supposed to write another chain over there. Why they are doing like that? How is that possible even? Okay, C is correct. Sorry, D is correct, isn't it? Because double bond is there. Sorry, double bond is there, right? Double bond is there. So this is the continuous chain. It's also incorrect. C is also incorrect. Cyclohexanol can be converted into cyclohexene, alcohol to alkene. What mass of cyclohexanol is needed to make 7.20 gram of cyclohexene if the yield of the reaction is 72%. You know what's the formula for percentage yield? That is equal to actual yield. That is equal to actual divided by theoretical multiplied by 100. Multiplied by 100 actual sorry, percentage yield is they have given that is going to be 72%, right? So 72% is equal to, that is going to be X. This is 7.20 grams multiplied by 100. Okay. So what's the answer? What's the answer? Let me calculate it. Let me calculate it. 72%, right? So multiplied by 7.2, it's going to be uh 12.2. It's going to be D, right? Okay. You can also solve this question like I can say that let's say if I solve this question in this manner, 72% of 7.2. 72% of 7.2. So what I would do, 7.2, what I would do, 7.2, yes, multiplied by 72 divided by 100. No? Or I can say that, let's say 7.2 for 100%, what would be the value? It's X. So X is equal to 7.2 multiplied by 100 divided by 72. It would be 10. By the way, it's the mass of cyclohexene, okay? Cyclohexene. So I can do, first of all, mole of cyclohexene, that is equal to mass over mR of cyclohexene, that is going to be 82. So I would be getting the moles, that is 0.122. Okay, since the mole ratio is same, that would be the same mole of hexanol as well. Then I have to find out the mass of hexanol. So mass is equal to mole multiplied by the mR of hexanol that they have given, it is 100. So that's why I'm getting 12.2 grams. That's why. This is also the method that you can opt. Okay, that's why they have given you the MR in this question. Okay, then the molecule shown has two double bonds. Okay, yes, we know that. What is the correct identification for each double bond? Okay, cis and trans isomerism, E and Z isomerism. So for this one, you can see it's a cis isomer, right? It's a cis isomer. No, it's not cis. Yeah, it's not cis. Because the higher priority groups are present on the opposite side, isn't it? It's a trans. Trans means E. E, E. We have two options, A and B. Then also we have to consider this. Okay. The the higher priority groups are present on opposite side, isn't it? So again, it's trans. So it's going to be A. It's going to be A. So how can I like define it? Higher, high priority, high priority groups, high priority groups are on opposite side. That's why they are going to be trans. And when is this is trans, it's going to be E. Cis is Z. That's all for MCQs. Okay. Then section B says sodium hydroxide can be obtained as a hydrate. Okay, when heated, the water of crystallization is lost, leaving anhydrous sodium hydroxide as shown in the equation. An experiment was carried out to determine the value for X. Okay. Procedure: weigh and record the mass of a clean, dry crucible. Add approximately this much grams of NaOH to the crucible and record the mass. Heat the crucible and its contents until a constant mass has been reached. After allowing to cool, reweigh the crucible. Okay, okay, okay. They have provided you the data. Oh my God, we have to complete a graph of the results by plotting the points, labeling the x's, including a straight line of best fit. Okay, means that before drawing the graph, I can say that that would be the best fit line. Okay, okay. So should I draw this? Okay. Uh, we can draw this. We can draw this. And before going to draw this curve, this graph, mass of NaOH in grams and mass of hydrated NaOH as well, right? So I can say mass of NaOH in grams. I'm going to take it on y-axis. And this is going to be mass of NaOH dot H2O. Right? Okay. So not looking good. Na, oi, oi. Okay. Um, then at 1, it's 0.69. At 1, it's 0.69. 0.69 would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0.1, 0.2, 0.3, 0.5, 0.6, 0.69 would be there. Okay. 0.69 would be there. And then at 2.1, it's 1.45. 2.1, it's 1.2345, like that. Okay. And 3.5, 2.41, 3.5, 2.41. It's 2, so it's 2.41. 4.9, 3.38. 4.9, it's gonna be 3.38. 1, 2, 3, 8. It's going to be like that. Okay. And then at 4 point, no, 6.6, 4.5. 6.60, 4.55. 4.55. This is 5. So 5 would be there. Yes. And the last one, I think, yeah, 8, 5.52. At 8, it's 5.52. 5.52 would be this one. Yep. Okay. Okay. Wow. Exact line we are getting. Okay. To determine the mass of NaOH dot X2O needed to form 4 gram of NaOH, you must show your working on graph 4 grams. So 4 gram is that. Okay, it's 5.8. It's nothing, it's 5.8. Okay, then calculate the value of X. I got the mass of NaOH, that is 4. Look at this carefully, it's an important thing. 4 grams. I can find out the mole of NaOH. 4 upon 40, MR of NaOH 40, 0.1 mole. I got the mole of NaOH. Okay. And I know that mass of NaOH dot XH2O is 5.8. From that graph, I got this number. Then I can find out the MR. MR would be equal to mole, that is 0.1, mass upon mole. Mass upon mole. So mass is 5.8 upon mole, that is 0.1. So the answer would be 58. So the answer would be 58, right? So after getting 58, what I can do, the total mass is 58. I can subtract the mass of NaOH, that is 40. I would be getting XH2O. So 58 minus 40 divided by 18, I would be getting X. That is going to be 1. So finally, X is equal to 1. Sodium hydroxide also forms the heptahydrate 7H2O. Calculate the mass of this heptahydrate needed to make 250 cm cube of a solution of sodium hydroxide of concentration 0.150 mole per decimeter cube. So first of all, I have to find out the number of moles. Okay, because mass is equal to Mr. moles. So I would be finding out the mole that is equal to concentration 0.150 multiplied by the volume, that is 250. Convert it in decimeter cube after dividing with 1000. So you would be getting the mole, that is 0.0375. Okay. And then I have to find out the mass. It's Mr. Moles. MR of MR of this one. MR of this one. 40 plus 7 into 18. It's going to be 166. So 166 times 0.0375. So you will be getting 6.2 grams. This is the mass of this heptahydrate. Okay, got it? It's very easy. So, okay.